Hello and welcome to Mr. Davis's classroom. This is Algebra 1, and today we're going over lesson 8-6, part 2. Last part, we went over factoring, AC factoring, or more specifically when we have an A value there other than 1. Today we're going to continue that lesson. All right, so right here we have the area of a triangle, or a rectangle, is equal to 2x squared minus 13x minus 7. What are the possible dimensions of the rectangle? Well, first thing that I want us all to realize that area of a rectangle is equal to length times width. And since we're dealing with polynomials, a length times a width isn't going to be something as simple as just, 3 times 7. Okay? In this case, area is going to be equal to two binomials times each other. So it might look something like x plus 2, x minus 1. That would be an example of area using polynomials. So now that we've seen an example, we know that what we need to get to. What we're going to do is we're going to take the area and we're going to factor it into two multiplied pieces. So since first thing I noticed that that's not A1, so I need to use AC factoring. AC is equal to 2 times negative 7, which is negative 14. And I'm going to make my x on the bottom is negative 14. On the top is what I need to add to, which is negative 13. Now, whenever I have two numbers like this where they're just one away from each other, I should always think that I'm going to be using 1 and a number. So in this case, I'm going to be using 1 and 14. I just need to decide which one of those two need to be negative. Well, since the sum or the add part is negative, I know the larger number needs to be negative. So let's just double check. 1 times negative 14 is negative 14. 1 plus negative 14 is negative 13. Okay, we got our numbers. Next step is to rewrite this in a extended polynomial. So 2x squared plus 1. Now I'm going to get to that negative 14. Remember what we have to do. We have to, 1x, there we go, plus a negative 14x minus 7. Remember that we want to make sure that we add the negative number, right? We don't want to put just a minus sign in there and call it good. And next step for us to do is to group symbols and find the GCF. What's the largest common factor between those two? Well, the numbers part is just 1. They both have an x. That is what's in common. On this other side, I have negative 14x and negative 7. But look at those two. I think negative 7 is my largest common factor. Quick check is to say, do those two numbers equal the same thing? When they do, we're going to combine them into one parentheses, and then what do we have left over? We have x plus a negative 7. Now it's safe to write just minus 7, so we can go back to simplifying it. Now, if we look at these two here, right, we found dimensions of the rectangle. Now, when we talk about dimensions, right, I'm going to write that area up here. Area is equal to length times width. Is there any way that I could decide which one of those two is length and which one is width? Well, traditionally, which one is longer? Traditionally, we call length the longer side. Which one of these set of operations will get me a larger number? Will minusing 7 get me a larger number? Or will multiplying by 2 and then adding 1 give me a larger number? What this tells me is that this side is my length, this side is my width. Okay, moving on. Here's one for you to try with area of a rectangle. All right, please pause, and if you need help, refer to the previous problem. Okay, now what we get here is some larger numbers. Now, I haven't made a point to factoring out a monomial first, or we'll call that a GCF first. But what we can do at any time to make a problem easier is look for a GCF. Now remember, a GCF stands for greatest common factor. Especially when we have large numbers, like what we have here, right? Some larger numbers. If I look at 18, 33, and 12, do they all share something in common? And I think if we look, they all share 3 in common. So the first thing I'm going to do is factor out my GCF, which is 3. So I'm going to pull out a 3, make my large set of parentheses signs, and then I'm just going to reduce each one, right? 3 times 6 is 18, 3 times negative 11 is, 3 times negative 11 is negative 33, and 3 times 4 is 12. Now, this 3 is just going to take a free ride all the way to the answer. I have a set of smaller, more reasonable numbers here to work with to do my factoring. Okay. All right, so still have an A value there. So we need to still do AC factoring, which is 6 times 4, 24. Multiply to get 24, add to get negative 11. Well, since I need to multiply to get a positive and add to get a negative, I know I need to have 2 negative numbers. When I look at this, I need to think about the type of numbers that go into 24. 24 and 1 don't work. 12 and 2 don't work. 3 and 8, looks like we got a winner there. 3 and 8. So a negative 3 and a negative 8, multiply to get 24, add to get negative 11. So like I said, this 3 is going to take a free ride down. And inside the parentheses, we're just going to rewrite our expression the same way that we did before. Now we need to combine our like terms. So we get 3 parentheses. What does 6x squared and negative 3x have in common? Well, they both are a factor of 3, and they both have an x. So we're left with 2x. And after this point, it is safe to write it as a minus sign and minus 1. Plus, what does 8x and 4 have in common? Now here is where we need to look ahead to make sure we do the right thing, okay? Because the quick answer would be 4, right? We're going to factor out a 4. But if I factor out a 4 from negative 8x, I'm going to be left with negative 2. And what do I want to match up? I want to be left with a positive 2. Okay. So that's why I'm going to factor out a negative 4 here. So then negative 4 times positive 2x is negative 8x. And negative 4 times negative 1 is a positive 4. Okay? So that requires just a little bit of foresight. And it's not a big deal. If we would have done it backwards, we would have got here and realized that those numbers were the same, but the signs were switched, and that we just need to fix that problem. So our inside parts are the same. It's time to rewrite those together. It's time to rewrite our first one, which is 3x minus 4. And also, that 3 is still taking the free ride all the way down. So this is the factored form of this. All right, try this one. Look for a GCF first, and then do AC factoring. Here's your homework assignment on 5-9. I hope you enjoyed, and thanks for stopping by Mr. Davis's classroom.